Hari Om. Hello everyone, I am Shri Jyoti. Welcome back to my channel. Today's video is of class 12 mathematics chapter 13 probability. From 8th standard itself we have been studying this chapter probability, right? We have studied that probability is a measure of uncertainty. For example, when we toss a coin, we know that what are the possibilities? We get either head or tail, right? So that is sample space. Sample space is equal to H or T. H and T, right? So here, what is the chance of getting head? There are two possibilities. So chance of getting head is only one H, right? So divided by total number of outcomes 2. We have studied that probability is nothing but number of favorable outcomes divided by number of total outcomes, right? So here number of favorable outcomes is 1 and number of total outcomes is 2. Therefore, probability of getting head is 1 by 2. What about probability of getting tail? That is also 1 by 2, right? So another example, when we rolling a die, so what is the sample space? The possibilities, we get either 1 or 2 or 3 or 4 or 5 or 6. There are 6 possibilities. So what is the probability of getting 5? What is the probability of getting 5? Number of favorable outcomes, that is 1. Only 1, 5 we will get, right? So 1, that is probability of this event. Event is probability of getting 5, right? So 1 divided by, that is number of favorable outcomes divided by number of total outcomes 6, right? So 1 by 6. Now what is the probability of not getting 5? So here not getting 5. Here 1, 2, 3, 4, 6. These can be possible but not getting 5. So here we write probability of E complement, that is equal to 5 by 6 except 5. So 1, 2, 3, 4, 5. Okay. So 5 by 6. That is here also number of favorable outcomes divided by number of total outcomes. Okay. Such event is called complementary event. Okay. And here see we notice that probability of E plus probability of E complement, that is equal to 1 by 6 plus 5 by 6, that is equal to 1. Okay. Probability of E plus probability of E complement, that is equal to 1. And okay, from this example, that is rolling a die. So here what is the probability of getting 7? There is no 7, right? Only 1 we get. When we roll a die, we get either 1 or 2 or 3 or 4 or 5 or 6, right? But there is no 7. Therefore, probability of this event is 0, right? Probability of getting 7 is 0. Now, what is the probability of getting less than 10? What is the probability of getting less than 10? See, all these numbers are less than 10, right? So 1, 2, 3, 4, 5, 6. There are 6 possibilities and we get 6, right? Number of favorable outcomes is 6, right? Less than 10. All these numbers are less than 10, right? Therefore, 6 divided by, that is number of favorable outcomes 6 and number of total outcomes is also 6, that is equal to 1. So here we noticed that probability is a number between 0 and 1. Okay, probability is a number that is between 0 and 1. So remember, probability cannot be negative or greater than 1. Okay, these all things we have already studied. So in this chapter, we will discuss about concept of conditional probability. Now let's go through conditional probability. What is a conditional probability? Conditional probability is a probability of an event given that another event is known to be occur. So here, see for example, let's take an example. Consider the random experiment of tossing a coin twice. Okay, tossing a coin twice. What is the sample space when we toss a coin twice? We get either HH or TT or TH or HT, right? It is the sample space. Now here we take let E be the event, E be the event, either two heads or two tails turn up. Okay, either two heads turn up or two tails turn up. It is the event E. Okay, let F be the event, F be the event, at least one tail turns up. Okay, F be the event, at least one tail turn up. Okay, one tail turns up. Okay, so here our question is, what is the probability of E? Okay, what is the probability of two heads or two tails turn up given that at least one tail turns up? Okay, so here the event F is already occurred. Okay, now let's write what are the possible outcomes of F. Possible outcomes of F is, that is, at least one tail turns up. At least one tail. So these three elements, right? So T, 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 H, H, T. Okay. Now let's write what are the elements of E. What are the elements of E? E is the event two heads or two tails, right? So H, H, T, T. Okay. Now what is the probability of E given that F? That is denoted as probability of E given that F. Okay, we read this given. Okay, E, probability of E given that this vertical line, we read this vertical line as given that. Okay, so that is equal to, now see, this event is already occurred. Okay, the event F is already occurred. Now what is the probability of E given F? So here we will select the favorable outcome of E from this F. Okay, that is, see, E is nothing but two heads or two tails. Okay, so here there is no two heads, right? So we select this TT, right? So TT, see, probability is nothing but it's a number. So that is only one element, right? So 1, that is number of favorable outcomes divided by total outcomes. See here, total means the number of elements in the F. Okay, given event, right? So 1, 2, 3. So 1 by 3. Okay, that is probability of E given F is 1 by 3. And here, see, we know that, see, what is TT? It is nothing but intersection of this E and F, right? E intersection F, that is equal to TT, right? E intersection F is TT. So here we can write it as probability of E given F is equal to number of E intersection F divided by number of F. Okay, that is number of elements of E intersection F divided by number of elements of F. Okay, in this way we can find the conditional probability. Okay. Now let's consider another example for conditional probability. Throwing a pair of dice. Okay, consider an experiment of throwing a pair of dice. So what is the sample space when we throw a pair of dice? What is the sample space? 1, 1, right? 1, 2, etc. 1, 6, 2, 1, 2, 2, etc. 2, 6, 3, 1, 3, 2, etc. 3, 6, 4, 1, 4, 2, etc. 4, 6, etc. 6, 1, 6, 2, 6, 3, etc. 6, 6, right? What is the number of elements in this sample space? 36, right? 6, 6 are 36. Okay. So here, let E be the event. E be the event. Sum of numbers obtained is 7. Obtained is 7. Okay. It is the event E. And given that F be the event, F be the event, first number on the odd number, okay, odd number on the first die. Odd number on the first die. Okay. So here we have to find the probability of E given that F has occurred. Okay. Probability of E given that F has occurred. So here the event F has already occurred, right? So now first of all let's write what are the possible outcomes of E and F. Okay. So here we know that possible outcomes of E are sum of numbers obtained is 7. So 1 6, 1 plus 6 7, right? 2 5, okay, 3 4, 4 3, then 5 2, 6 1, right? These are the outcomes, possible outcomes of E, okay, event E. And what are the possible outcomes of event F? See, F be the event odd number on the first die, odd number on the first die. So 1 1, 1 2, etc. 1 6, 2 is not possible, 3 1 because odd number on the first die, right? So 3 1, 3 2, etc. 3 6, etc. 4 is not possible, 5, okay, no need to write it, okay, 5 1, 5 2, etc. 5 6. Okay, now here we have to find the probability of E given that F has occurred, right? So what is the probability of E given that F? That is number of E intersection F. Or here we have to find the probability of E given that F has occurred. So we have to consider the event favorable to E, okay, given that F has occurred. Okay, so from this we have to select. Okay, so here 1 6, 2 5, 3 4, 4 3, 5 2, 6 1. So what is the intersection of E and F? That is 1 6, right? 2 5 is not possible. 3 4 and 5 2, right? Therefore, what is the number? 3, right? 3 divided by how many elements are here in the event F? 18, right? So 18. So 3 divided by 18, that is 1 by 6. Or you can find, we know that probability of E given F is number of E intersection F. E intersection F is nothing but 1 6, 3 4, 5 2. 1 6, 3 4, 5 2, right? That divided by number of F, that is 18, right? So 3 divided by 18, 1 by 6. So here the formula is probability of E intersection F. We know that number of E intersection F divided by number of F, right? So this can be written as here number of E intersection F divided by number of S, that is sample space, total number of elements in the sample space, divided by number of F divided by number of S. Okay. Now what is it? It's nothing but probability of E intersection F, because we know that probability is the number of favorable outcomes divided by total number of outcomes, right? So here it is nothing but probability of E intersection F. So it is equal to probability of E intersection F divided by, see this one, it is nothing but probability of F, right? So probability of F. So it is the formula to find the conditional probability, that is probability of E given F is equal to probability of E intersection F divided by probability of F. Now let's go through properties of conditional probability. First property, let E and F be events of a sample space S of an experiment. Then we have probability of S given F is equal to probability of F given F is equal to 1. Let's prove it. probability of S given F. What is the formula? Probability of S intersection F divided by probability of F. Right? And obviously F is the subset of S. Sample space S. Right? So here, therefore S intersection F is nothing but F itself. Right? S intersection F is F itself. Since F is the subset of S. Right? So probability of S intersection F is probability of F. Right? Divided by probability of F. That is equal to 1. Now let's take this one. Probability of F given F. That is equal to probability of F intersection F divided by probability of F. That is equal to, what is probability of F intersection F? F intersection F is F itself, right? So probability of F divided by probability of F, that is equal to 1. So remember, E and F be the events of a sample space S, then probability of S given F is equal to 1. Okay? And probability of F given F is equal to 1. Second property, if A and B are any two events of a sample space S and F is an event of S such that probability of F not equal to 0, then probability of A union B given F is equal to probability of A given F plus probability of B given F minus probability of A intersection B given F. It's very important. So let's prove it. Here, probability of A union B given F, that is equal to probability of A union B intersection F divided by probability of F by the formula, right? That is equal to probability of A intersection F union B intersection F divided by probability of F, right? So here, what is probability of A union B? Probability of A union B is nothing but probability of A plus probability of B minus probability of A intersection B. We have already studied this, right? So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So let's apply this formula here. Probability of A union B, right? So probability of A intersection F plus probability of B intersection F minus probability of A intersection B, right? So A intersection B intersection F, right? So A intersection B intersection F divided by probability of F. Now split this numerator. So probability of A intersection F divided by probability of F plus probability of B intersection F divided by probability of F minus probability of A intersection B intersection F divided by probability of F. Okay, so what is it? By the conditional probability formula, we can write probability of A intersection F divided by probability of F is nothing but probability of A given F, right? Probability of A given F plus it is probability of B given F minus, say it is probability of A intersection B given F, right? Probability of A intersection B given F. See here, what if A and B are disjoint sets? It is given if A and B are any two events of sample space S, right? If A and B are disjoint sets, means there is no common element, then the formula will be probability of, this will be 0, right? Intersection A intersection will be null set, that is probability of A intersection B given F will be 0, right? Therefore, if A and B are disjoint sets, then probability of A union B given F is equal to probability of A given F plus probability of B given F. third property of conditional probability, probability of E complement given F is equal to 1 minus probability of E given F. So here, say we know that E union E complement, that is the union set. We know that here sample space is the union set, right? So here we can write E union E complement is equal to the sample space, right? So here we know that probability of first property, probability of S given F is equal to 1, right? So this can be written as probability of E union E complement given F, right? Because E union E complement is the sample space, right? So E union E complement given F, that is equal to 1. And here E and E are disjoint sets. Sorry, E and E complement are disjoint sets, right? There is no common element, right? Because E complement is the complement of E, right? So here, therefore, by property 2, we can write probability of E given F, okay, plus probability of E complement given F is equal to 1, okay. What is our property 2? The property 2 says that A and B are any two sets of sample space, then probability of A union B given F is equal to probability of A given F plus probability of B given F minus probability of A intersection B given F, right? But here E and F, E intersection E complement is null set, right? Therefore, the third term will be 0. So here probability of E given F plus probability of E dash given F, okay. So here from this we can write probability of E complement given F is equal to 1 minus probability of E given F. Now let's go through exercise 13.1. First question. Given that E and F are events such that probability of E is equal to 0.6, probability of F is equal to 0.3 and probability of E intersection F is equal to 0.2, find probability of E given F and probability of F given E. Okay, let's find probability of E given F. What is the formula? Probability of E intersection F divided by probability of F, that is equal to, it is given probability of E intersection F is 0.2 divided by probability of F is 0.3, that is equal to 2 by 3. See here, no need to write it in decimal form, because here we usually express the probability values in fraction form, okay. So next is probability of F given E, that is equal to probability of F intersection E or E intersection F, both are same, okay. Probability of E intersection F divided by probability of E, okay. Probability of E intersection F divided by probability of E, that is equal to probability of E intersection F is 0.2 divided by probability of E is 0.6, that is 2 by 6 is equal to 1 by 3. Compute probability of A given B if probability of B is equal to 0.5 and probability of A intersection B is equal to 0.32. So here we have to find probability of A given B. Formula is probability of A intersection B divided by probability of B. Substitute these values, these are given. Probability of A intersection B is 0.32 divided by probability of B is 0.5. So how to find this one? Here after decimal 2 digits, so here we have to multiply 100 by denominator. So and in denominator after decimal 1 digit, right? Therefore multiply 10 by numerator, okay. So 320, here add 1 0 because after decimal 1 digit in denominator, divided by here after decimal 2 digits, therefore we have to multiply here 100, therefore 500, okay. So 0 cancelled, 32 by 50, so 16 divided by 25, okay. probability of A is equal to 0.8, probability of B is equal to 0.5 and probability of B given A is equal to 0.4. Find probability of A intersection B, probability of A given B, probability of A union B. It's very important question. Now let's find one by one. First is probability of A intersection B. We have to find probability of A intersection B. Here it is given probability of B given A, right? So probability of B given A is equal to probability of A intersection B divided by probability of A, right? So here probability, this implies it is given, right? That is 0.4 is equal to probability of A intersection B divided by probability of A is given 0.8. That implies probability of A intersection B is equal to 0.4 into 0.8, that is equal to 0.32, right? Next, second one, we have to find probability of A given B. That is equal to, what is the formula? Probability of A intersection B divided by probability of B. That is equal to probability of A intersection B is 0.32 divided by probability of B is 0.5. That is equal to 16 divided by 25. Right? Next is third one, probability of A union B. That is equal to, what is probability of A union B? Probability of A plus probability of B minus probability of A intersection B. It is the property of probability, okay? So probability of A 0.8 plus 0.5 minus probability of A intersection B is 0.32. That is equal to, see, 0.8 plus 0.5 is 1.3 minus 0.32, right? So it is 8, 9, right? So 0.98. Evaluate probability of A union B if 2 into probability of A is equal to probability of B is equal to 5 by 13 and probability of A given B is equal to 2 by 5. Okay. So here let's write what are given. Probability of A is equal to 2 into probability of A is equal to 5 by 13. Therefore probability of A is equal to 5 by 13 into 2, 36. Sorry, 26, right? 5 by 26. And probability of B is equal to 5 by 13. Probability of A given B is equal to 2 by 5. Okay. Here we need to find probability of A union B. We know that probability of A union B is probability of A plus probability of A B minus probability of A intersection B. So we need to find probability of A intersection B, right? So for that it is given probability of A given B. From that we will find probability of A intersection B. Probability of A given B is equal to probability of A intersection B divided by probability of B, right? That is probability of A intersection B, that implies it is given, right? So probability of A given B is 2 by 5, that is equal to probability of A intersection B divided by probability of B is 5 by 30, right? That implies probability of A intersection B is equal to, take this one here, so 2 by 5 into 5 by 30, right? That is equal to 10 by, okay, 5 cancelled, so 2 by 30. Okay. Now let's find probability of A union B. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. That is equal to, what is probability of A? 5 by 26 and plus probability of B is 5 by 30, right? Minus probability of A intersection B is 2 by 30. that is equal to, here 5 minus 2, 5 by 26 plus 3 by 13, that is equal to 5 by 26 plus 6 by 26, that is 11 by 26. If probability of A is equal to 6 by 11, probability of B is equal to 5 by 11 and probability of A union B is equal to 7 by 11, find probability of A intersection B, probability of A given B, probability of B given A. Say probability of A, probability of B and probability of A union B are given, right? So how to find probability of A intersection B? We have a formula, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, these three terms are given, right? So that we can find this probability of A intersection B. So let's substitute these values. 7 by 11, that is equal to 6 by 11 plus 5 by 11 minus probability of A intersection B. That implies probability of A intersection B is equal to, taken this probability of A intersection B left side and take this 7 by 11 right side. So 6 by 11 plus 5 by 11 is 11 by 11 minus 7 by 11, that is 4 by 11. 4 divided by 11. So next second one, we have to find probability of A given B. Probability of A given B formula is probability of A intersection B divided by probability of B. That is equal to probability of A intersection B we have found, that is 4 by 11 divided by probability of B is given 5 divided by 11. 11 cancelled. So it is 4 by 5. Third one, probability of B given A. That is probability of A intersection B divided by, A intersection B divided by probability of A. Okay, probability of A. That is equal to probability of A intersection B is 4 divided by 11 divided by probability of A is 6 divided by 11, that is equal to 4 divided by 6. Look at the next question. Determine probability of E given F. A coin is tossed 3 times where first one E be the event head on third toss, F be the event head on first 2 tosses. Okay, so here we have to find the conditional probability of the event E given that F has occurred. Okay, so first of all we have to write the sample space when we toss a coin 3 times. What are the possibles? What are the possibilities? Sample space S is equal to HHH, HHT, HTH, TTH, HTH, right? Then THT, THH, TTT, right? Okay, so here now we will write the possible outcomes of event E. Okay, first one, possible outcomes of event E. What is the event E? Head on third toss. Okay, head on third toss. Okay, now let's write E. The possible outcomes of E are HHH, then HTH, TTH, then THH. Okay, these are the elements of event E. Then next let's write possible outcomes of event F. Okay, event F. head on first two tosses. Okay, here first two H should come. Okay, here see what are the elements? H, 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 then H, H, T. That's all, right? Okay, because it is given head on first two tosses. Okay, now we have to find conditional probability of E given that F has occurred. Okay, so here you just apply the formula. Probability of E given F is equal to probability of E intersection F divided by probability of F. What is the probability of E intersection F? So here probability of E intersection F is, see what is E intersection F? E intersection F is nothing but H, 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 right? H, H, T is not there. Okay, H, H, H. So probability of H, H, H is nothing but 1 divided by, that is number of elements in the sample space, that is 8. Okay, divided by probability of F is 2 divided by 8, right? So 2 divided by 8, that is equal to 1 by 2. Or you can write directly, that is, see what is the common element? H, 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 that is only one element, right? So 1 divided by this one, total number of elements in the element in the event F. So 2, right? So directly you can write 1 by 2. Okay. So 1 by 2 is the answer. That is probability of E given F. Next, let's go through second. See second one. Here E be the event at least 2 heads. At least 2 heads. So more than 2 heads can be possible, right? So 2 or more than 2. So the event E, the possible outcomes of E are at least 2 heads, right? So H, 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 then H, H, T, then H, T, H. Okay, at least 2 heads. Therefore, this one not possible. There is only one head. It is not possible. It is not possible. This one, T, H, H. Right? Okay. These are the elements of event E. Next, F is the event at most 2 heads, right? At most 2 heads. Means not more than 2 heads. At most 2 heads. So here, F is equal to at most 2 heads, H, H, T, then H, T, H, then T, T, H is possible, right? Because at most 2 heads means less than or equal to 2, okay? So T, T, H, then H, T, 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 H, T, okay? T, H, H, then T, 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 okay? So here 0 head is also possible. Why? Because it is given at most 2 heads. At most 2 heads means it is less than or equal to 2. Okay. So 0 head is also possible. So HHT, HTH, TTH, HTT, THT, THH, TTT. Okay. Now, what is the probability of E given F? Probability of E given F. What is the intersection? What are the elements in intersection? That is HHT, okay, 1, then HTH, okay, 2, then THH, 3, right? So 3 elements, right? So 3 divided by, okay, what is the total number of elements in F, event F? That is, because we have to find the probability of E given F, okay? Or you can apply the formula also, probability of E intersection F divided by probability of F. So here, probability of E given F is equal to, here there are 3 elements in common, right? That is HHT, okay, then HTH, then THH, right? So 3 elements divided by 1, 2, 3, 4, 5, 6, 7. 7. Right? So 3 by 7. Or you can apply formula. See, probability of E given F, that is equal to probability of E intersection F divided by probability of F. Right? So what is probability of E intersection F? E intersection F is 3 elements, right? So 3 elements. So probability of E intersection F is 3 divided by, that is number of elements in the sample space, that is 8, divided by probability of F is nothing but number of elements in the event F divided by total number of elements in the sample space. That is the probability, right? Here a number of probability is equal to number of favorable event outcomes divided by total number of outcomes, right? So here probability of E intersection F has 3 elements, okay, divided by total number of elements in the sample space, that is 8, divided by, here probability of F is number of elements in the sample space, number of elements in the event F divided by number of S, that is 8. So 8 cancelled, that is 3 by 7. Okay. Okay, let's find the conditional probability of third one. Here E is the event at most 2 tails. Okay, now let's write the possible outcomes of E. Event E is equal to, here at most 2 tails. So tails should be less than or equal to 2. Okay. So tails should be less than or equal to 2. So 0 tail is also possible. Therefore H is possible, right? So here HT. Okay. Here there is only one T. Then HTH. Then TTH. HTT. THT. THH. TTT is not possible because at most 2 tails. Okay, less than or equal to 2 tails. Then what is the event F? Event F is at least 1 tail. Okay, at least 1 tail. So greater than or equal to 1. Okay, so F is the event. The possible outcomes of F are at least 1 tail, right? So HHT, HTH, TTH, HTT, THT, THH, TTT. Okay. Now we have to, here also we have to find the probability of E given F. Okay, let's apply the formula. See, to find the we have to find the probability of E given F, that is nothing but probability of E intersection F divided by probability of F, right? So what is the E intersection F? Set of elements of E intersection F is E intersection F. These are the elements of E and these are the elements of F. So what are the intersection? What is the intersection of these E and F? See here, HHT, HHT, then HTH, TTH, HTT, THT, THH. That's all, right? How many elements are here? 1, 2, 3, 4, 5, 6. Okay, 6 elements. So what is the probability of E intersection F? That is 6 divided by 8, right? 6 divided by 8 divided by probability of F. F has 7 elements. So 7 divided by 8. 7 divided by 8. 8 cancelled. So 6 divided by 7. Determine probability of E given F. 2 coins are tossed once where E is the event, tail appears on one coin, and F is the event, one coin shows head. Okay, so here also we have to find the conditional probability of E given that F has occurred. Okay, and the experiment is 2 coins are tossed once. Okay, so first of all let's write the sample space. Yes, so what is the sample space? What are the possibilities when we toss 2 coins once? HH, HT, TH, TT. Right? After that, let's write the possible outcomes of E. Possible outcomes of E. E is the event tail appears on one coin, any coin, first coin or second coin, okay, but one coin should be tail, okay. So here that is HT, TH, right? One tail appears on one coin, okay, any coin, first coin or second coin, it may be first coin or second coin. So HT, TH, okay, TT is not possible because one coin, one tail, okay. Next is F is the event. What are the possible outcomes of F? F is the event one coin shows head. Any coin, first coin or second coin. So one head should be shown. Okay. Therefore, HT, TH. That is also HT, TH. Okay. Now, here also, what is the probability of E given F? Probability of E given F is equal to, okay, if we using the formula, then probability of E if intersection F divided by probability of F, right? Now, what is E intersection F? E intersection F is equal to, see, two elements, right? That is HT and TH, all the elements, right? So, and next is, what is probability of E intersection F? That is number of E intersection F divided by number of sample space. That is the probability, right? That is number of favorable outcomes divided by number of total outcomes. So here number of E intersection F is 2. 2 divided by number of sample space, number of elements in the sample space is 4, right? So 2 by 4. Next, probability of F. What is probability of F? Number of elements in F divided by number of elements in sample space, right? So number of elements in F is 2. 2 divided by 4. Therefore, it is equal to 2 by 4 divided by 2 by 4, that is 1. Or you can write it directly, that is E intersection F. What is the E intersection? See how many elements are there? 2 elements, right? E intersection F has 2 elements. 2 divided by number of elements in F, okay, because it is E given F, right? So number of elements in F is also 2. So 2 by 2, that is equal to 1. Second one, E is the event no tail appears and F is the event no head appears, okay. So here let's write the elements of E. What are the possibilities of possible outcomes of E? No tail appears, okay, therefore HH. Here these are not possible, okay, both coin it should be head, okay, no tail, therefore the element is HH, only one element, that is HH, okay. And F is the event no head appears, okay, therefore here TT, right. Now see, E and F has no common element, right, therefore E intersection F is equal to 0, right, that is null set, okay. E intersection F is null set, therefore probability of E intersection F is 0. So here probability of E given F is equal to probability of E intersection F divided by probability of F, that is equal to, see here E intersection F is equal to null set. Therefore probability of E intersection F is 0 divided by number of sample space, that is 0, right. Therefore it is 0. Okay, probability of E intersection F is 0. Therefore, probability of E given F is equal to 0.